Hi everyone, today we are going to solve a day 14 challenge, which is to find or check a number is a prime or not. In previous videos we are going to the day 1 to day 13 challenges. Today is the day 14 challenge, that is to find a number is prime or not. So here I am defined a function to find that a number is prime or not. Normally, let's try to find or know about a how a number is a prime or not. We have to know about that, right? So let's find about that. So a prime number is a number so that has only two factors. So it is the main point to keep in mind that prime number has only two factors, so which is 1 and the number itself. So here for example, for 2, the factors are like 1 and 2. 2 into 1 is equal to 2, right? Same as like 3, 5, 7, 11. We can't get the 2 by multiplying different numbers, right? So same for all these numbers also. We can't get 7 by multiplying 2 or 3, 5, 6. No, just we get 1 and 7, right? So the number itself and the 1 are the two factors for the prime numbers. So that number is called the prime number, right? So not prime numbers are like this. So 4 divisible by 2. So 4 can get by 1 into 4 and 2 into 2. So these are like a 1 is a factor, 2 is a factor, 4 is a factor. So there are the three factors for that 4, right? So 4 is not a prime number because it has the three factors, right? So prime number, we should say that it should have the only two factors, which is 1 and the number itself. But here I am saying this a number of times because we can confuse about that what is the number itself, and sometimes maybe some members like me, like we are like confusing about these words, right? So that's why I'm repeating the words about like only two factors, and if there are more than two factors we call them something like that. Okay, so let's go through that, like what is a prime number, what is like. So prime number is like a number can be divided by 1 and itself, we've seen that, right? So it is like a saying that 2 is a prime number because only have the 1 and 2. Same like 3 also, but 4 and 3 are not prime numbers because divided by numbers other than 1 and number themselves, right? So if we get the factors as more than 1, like for example here we get only two factors. If we get more than 2, then we called as composite numbers, right? So composite numbers is like a more than two divisors. In other words, it can be divided by 1 itself and at least one other number. So here 4 is like this, where it can divided by 1, 2 and 4. So here we have the three factors, right? So it is a composite number. C is also same as like that, right? Sorry, 6 is like a same like that, 1 into 6 and 2 threes are 6. So there's a four factors here. So if a number is not prime, meaning it it has more than just one, or it is divisors, means like a more factors, right? Divisors, factors, what we can say it is like it is a composite number. So 1 is a really not a factor, not a prime number, right? Sorry, not a prime number and composite number. Okay, so what about the negative numbers? Negative numbers is also not a prime numbers and composite numbers. So these all are like a positive integers only. Okay, normally we say like that, right? Let's see what is a type of numbers, like natural numbers, whole numbers, integers, rational numbers and irrational numbers, which is like this. These are all real numbers. So these are like real numbers, and composite numbers are like, sorry, complex numbers are like we will get the I type, right? So let's get into the previous slide. Okay, so where a number should be prime or also a prime composite number, right? That is they means like the numbers that are neither prime nor composite is like 1. Okay, 1 is neither prime number nor composite number because it has only one divisor itself, which means like 1 into 1. So 1 into 1 we get only 1. So here the factor for the same here like a similar, right? So similar one factor is like only one factor. Okay, I mean you get it like right. I mean you get my point, right? So it has only the one factor only, means one factor, same one is a one factor, right? So it doesn't meet the definition of the other. Prime means it should have only two factors, and composite will have more than two factors. So negative numbers are also neither prime and composite, because prime and composite numbers are defined only for the positive integers which is greater than 1, right? So it is giving the summary about this point. So here like a there is no number that is both and composite number at the same times. Okay, don't confuse about this. I'm saying that I have gathered the simple points about what is a prime number and what is composite number. So by getting these points we can easily solve the problems by getting the loops, or means like you are you getting my point, like we can understand the logic using in that programs. Okay, so that's why I have searched and used this terms to check it is a what is a prime and what is a composite and how is the going that there and like that. Okay, mostly. Okay, and we all have doubt about 1 and 2, right? So I have gone through this. 1 is neither prime or composite, as I have said. So since 1 has the one divisor itself, so it doesn't meet the definition of the prime number, and also it doesn't meet the definition of the composite number. So where it composite numbers, we should have the more than two divisors, right? More than two divisors. So 2 is a prime number. Here prime number is a positive number since it is a greater than 2, sorry, greater than 1. So that have exactly two divisors, right? So we can consider it as a prime number. And you have here 2 is the even prime number, only the even prime number in the prime numbers. You know that it is the one and only even prime number. So 2 has the exactly two divisors. It can't divide evenly by any other numbers besides 1 and 7. Okay, so interestingly 2 is only even prime number. Yes, because all other even numbers are divisible by 2, right? So meaning they have more than two divisors, making them composite, right? So that's why it is a 2 is a even, only the even prime number. Okay, and next yeah, it's showing like with examples. And yes, it is showing that three years are like a just like going to the examples of the prime numbers, composite numbers, where 3 have the only 2 and these are more, right? So just saying that. And it is also same have asked about, can't get, because I'm also confused with the one what is the same thing like. So have get these points. Okay, single divisor, I mean like have the one same one, so that's why it's having one factor. So it is not a neither prime nor a composite. So keep in mind that, because this logic will be used in the Python programs now after next this topic, right? So that's why I'm searched about this. So next, and yeah, this over. And you can also find that composite in a prime number have exactly two distinct divisors, and 2 is the prime number because it is, and 4 is a composite. So let me go through all. Like for example, prime numbers is like this, will it will be more than also. So it can be divided by evenly by the integer other than, okay, sorry, cannot be divided evenly. And so 2 is the smallest and only the even number, so it is the first prime number also and only the even number also. Okay, and smallest number also, means like first, smallest and only even prime number, and all other are like odd, and with exception of 5 cannot end with 5. Okay, numbers greater than that are not prime are called it is, right? So means like they are like more than two factors, right? So in the composite also 4 is the first prime number. You can also observe this photo, means image, 4 is the first composite number, and 2 is the first prime number. So that is mostly asked in any interviews or any logic, we can use that. Okay, and in a prime numbers, odd primes are greater than. Okay, and last digit except 5, no other prime numbers ends in 5. Also all prime numbers are greater than. Okay, I think I don't. Yes, yes, good. No largest prime. There is no largest prime number. Mathematicians have the proven that there are infinitely many. Okay, so real the applications to use in this. Okay, so these are the properties that smallest and only even two. Okay, have said, and yes, means we have discussed, right? So the number 6 is a composite because more have the contrast. Okay, and more than two factors and can be broken down multiplying to something, like not prime. By defining the number is positive integer greater than 1, that is not a prime. Yes, means that points we have to keep in mind that about like this. Mostly prime factorization will be like this. Okay, next. Okay, so it is just like have gone through that what is this and what is the square roots, and I mean like a how we go through the check a prime number in not in Python logic. Okay, just to check it is a Python prime number or not, right? So let's get into this and let's check what is the hints the ChatGPT has given to find this. So we have to write a program to check whether a number is prime or not. So okay, prime firstly lastly telling about this. Okay, a prime number is a number that has only two factors, 1 and the number itself. Okay, these are the examples, and not primes are this, which means these are also a composite numbers. If there are negative and ones, that are also not a composite and prime numbers. Okay, so first to use the logic, first we have to take a number from the user, and a number should be first, means we have to check this and start dividing from this from 2 to n minus 1. If the number is divisible by these, it is not a prime. So okay, so let's try to do that. So I'm closing this sidebar. Okay, so it is by using, which means by using loop, let's say loop. Okay, so firstly have to check, means I have to take in the input from the user. Let's say it is a user from we have taken, and next step is like to check it is less than or like, means I have said if it is a negative numbers or 1, it is not a prime number. So if num is less than or equal to 1, then we have to directly return false or not a prime number, whatever. Let's say I'm saying false. Okay, or like okay, let's say not prime. Next, what if else, right? Else part, if the number is greater than 1, which means that is a positive number, so we have to go through the loop, right? What for I in range, let's say I'm pass. Okay, so for that start dividing the number by all the integers. So first I have to divide the number, so from what, 2 to n minus 1, means I'm directly giving number because the range function will automatically removes the last one, right? So I'm not considering that n minus 1. So we have to check, what we have to check, that start dividing the number by all the integers. So I have to divide first number divided by 2, means it is an even number. Okay, it is not equal to 0, means it is odd number. Okay, then we have to return if it is not equal to, means let's say it is equal to 0, directly we can say, then we can directly return false, and we can return true, right? Let's check, means let's try to run, then I can understand and you can understand all these things. Okay, here getting that. Okay, I think the screen, let's say I will say first one is true, so it is a prime number, and other all are like a not a prime number, so that is a false. So it is checking. Okay, I'm only divided by 2, but I have to divide it by I, right? I'm so confused. Okay, so again we get the same answer, true, true, false, 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 because mm, the I is 2. So for example 29 divided by 2 is it is will really get, means is it divisible by 2? No. So next gets the next number 3. Then 3 divided by 29, no, that that does not happen. So next goes for the 4, and 4 divided by 29, no. The same for the till the n means number means 29 for the till 29. Here we get the n minus 1, right? So almost like a 28. So 2 to 28. In that numbers, it can't divided by any number, right? So we can directly say it is a true. If it is not divide, then it doesn't return false. It can return true, right? So it does checking here. Here I am not using 29, means like plus 1, because if it is divisible, then we can say okay, if it is divisible, then we can return say it is a false. But 29 itself, we prime number means what? It can divisible by 1 and number by itself, right? Means it can divisible by 1 and it can divisible by number itself, like 29 by 29 is equal to 1. So it can divisible, so we can't include that number also. So that's why we have used like this, and we have started from 2, not from 1 and 0, because both the numbers are not prime. Okay, so that's why we have used this logic to that. So I'm running again, same, we get the 29 is a true prime number, and false, false, false. We can, if you have any doubt with the 2 also, we can directly include 2, then it is also a true function. Yes, run this file. Okay, true, true, false, false, false. Okay, it is also a prime number. And next, check with that what is the logic that ChatGPT is used. Yes, same logic it is used, that to checking each number it is divisible by 0. I mean it is divisible each number or not. So if it is not a prime number, we can directly say, means I have said here like false, and here it is saying that directly we can break that. Okay, here return function directly breaks that, so that's why I have not used any break word keyword, right? So yes, it is used, and the number divisible is equal to 0 means it is divisible by anyone, so it is not a prime number. So prime number is, it is not divided by any number, right? So it only divides 1 and the number itself, means the number, so it does not have to divided by any number. So that's why we use this. If the number is does not divided by any number, so it is a prime number. If it is divisible, then we can say directly it is not a prime number, right? So the else part in the, okay, the else part in the means like if it is breaks, then it can't, means like it is the else part of the for loop runs only the loop didn't break, which means no divisor was found, so hence it is prime. So okay, these are the edge cases, like said I have said like negative numbers are not a prime, 0, 1, 2 are also not a prime. So if it 2 get, we have to say it is a prime, and large number means we have to say prime. But here, yes, so here there is a time complexity will be more, because we have to check with each number till, for example, if the number is 1000, we have to loop that much, so we have to optimize the logic, right? So in the next approaches we can that. In this concept we have used like a for, break, else, and conditional checks, and modulus operator. This is the modulus operator which gives the reminder of that. Means division means normally we use like it is a something like a division, right? Means we get the coefficient and divisor and divide and dividend dividend, something like that in that reminder we get the output, right? That will return the modulus operator for the dispute, right? So yeah, here the number of approaches going through, that is like basic loop, right? This is the simplest and easiest to understand. We check the divisibility by every number from 2 to n minus 1. Okay, so this is here we have used like that. Okay, same as like that, and checking if divisible not a prime. Yes, right. Next we have here checking that, means it had explaining that we check the each number and none, if none, that is like prime. See, time complexity will be more big of, and means like running each number, right? And space complexity is okay with that, not efficient for the large numbers as I said above. Okay, these are like edge cases, minus 5, 0, 1, 2, 3, where these are the prime numbers. Last 2, 3, 5 are like a prime numbers, and 10 is not a prime number, right? Because they have the multiple factors, right? Next, optimized approach. Check optimized approach with the square root method. Here you don't need to check all the numbers up to n minus 1. Here the most important word here. So we have to not check up to n minus 1, means if there are 1000 numbers, and we don't need to check for until that last number. Here the square root method will reduce that, will optimize that method, right? So if a number has a divisor larger number root n, then the corresponding smaller divisor will already have been found before that. Means firstly I'm also not understand about this, so that have used the ChatGPT help, and then I get understanding about this. Okay, I will explain this. So understand the square root method. The key idea is that the number has divisor larger than, means for example, if the n is 36, its divisors are like this. Notice that here if we check this, means 36 square root is 6. We already encountered the smaller divisors like 2, 3, 6, right? So the larger divisors like 9, 12 are just paired up with the small ones. For example, here for the 9 we can go directly with the 36, right? Means so let's try to go through the how, what is the like square root, and so we can get an understanding how it like this. So square root is like abbreviation of square root, and what is that like, same like this. For example, square root of 16 is 4, because of 4 into 4 is 16, right? So every number has two square roots, one positive and one negative. Example like this and this, so equals to 4. So but square root usually refers to the first one, right? So here given like a root of 9 is 3, because 3 into 3 is equal to 9. So same as like points to know, like mostly we have used like this, and x power 2 is equal to n, right? So mostly and positive numbers and like this, and inverse function like finding the square root or is the inverse operation of squaring a number, right? So these are like a concept of this. So let's try to check here, so you can understand when we go through the how the process will go. We mostly have used like this, means like looping from 16 with, like for the looping up to 16 we can directly use the square root and we get directly the 4. So it is like it is the one of the divisor of the 16, right? So we can find in the mostly in the front side, like in the first time, like 1 2 3 4. Okay, 4 is gonna divisor of the 16, so it divides the number, so it directly means 2 also divides, right? So we have another approach to checking only for the even numbers also. For that aside, just here checking about like only the square root. Okay, so we can check means that direct divisor. So if that number divided by both, so we can directly say it is not a prime number, right? So same for this, like for example, let's go through the each step in that program so we can understand about that. So first take the input, and it is a basic condition to check whether it is a it is like a number or like previous numbers, and here we have used the variable to that to store the math square root, means that is to calculate the square root of a number, limit for checking the divisors, right? So we have to check for the divisibility for from 2 and to the square root 2. Here does checking divisors from this, I mean that also including this square root number also, means that's like 4 also, not just only for the 3, it is also including 4, right? Because range function will remove this. So normally checking each number with that, if it is divided evenly, no reminder. So means that we have to just no need to check the further if it is divisible, so that is not a prime number. So if it is not divides by any number, so we can directly say it is a prime number, right? So here you can understand easily about using the square root with examples, that it shows the process how it's going. So here we use the square root to avoid the floating point errors. So we use to convert that float, means when we use the square root, it gives the I think maybe in this okay, okay, so let's go to that. Okay, when use the square root of any number in this in Python, it gives the floating point numbers, or any number we have to, when we do the square roots, it will gives in a floating point numbers, means taking decimal number. So we used to convert that number into the integer, right? This gives the limit up to which will take the check, we will check the divisibility, right? So look to from this, and this is why we use this limit, and for each I we check if it divides and evenly, right? Means there is no reminder, so as like we seen above, else we gone through. So here you can clearly understand, let's say it is a prime number as we seen in the previous uh, in that, so that it shows it is a prime number, we know that. But to checking in using by Python logic, so here is the process to that. So square root of 29 is like 5.39, so we have to convert that into integer. Then we will check if it is divided by 2, no. Divided by 3, no. Divided by 4, no. Not divisible, means remainder is not equal to 0. And it is also divisible not by the same this number also, so it is, we can say directly it is a prime number, right? Since no divisors was found. So let's say for look at the 30 also, so that is greater than 1, so we can proceed, right? So calculate that, and it is a 5, approximately we can say 5, right? So loop through 2 to 5, and checking the divisible, remainder is equal to, directly we can get by using 2, right? So we found a divisor, so we immediately print not a prime number, right? So we can exit the loop. So why it is efficient means, normally we have to go through up to n minus 1, which may the number of for the larger numbers it becomes like inefficient. So with square root optimization, we directly do check with the square root. For example, for 100 numbers, instead of checking all up to 99, we only check up to 10 directly, means square root of 100 is equal to 10, right? So which drastically reduces the number of checks, right? So this makes the optimizer run faster, especially for the large numbers. The time complexity will also be like this, and which is like more faster, right? Checking from and means like comparing with the n, we can directly, we can say that is it is most optimized approach, right? So okay, let's try to write that. Sorry, let's try to write that. Okay, okay, let's comment out this, or like we can use this. Okay, let's try commenting out. What is the approach is by using square root. So for that I have to import a square math module, right? Import math. So for that I have to use So here the else part will be run, right? So okay, so here normally I have used in from the above, so I'm leaving about that. So it is the else part, directly checking with each one. So else is equal to, it is directly defining a variable by giving int of, right, math dot square root of a number, right? So I'm directly converting that into a number, sorry, integer, right? So for that I have to check in each number in the range of 2 to limit, right? I'm also including that last number limit method also. Okay, so if number is divisible by any element I is equal to 0, then we can directly return false. Else we can return directly, we can return true, right? Here also same date on this, just I'm running the file, so same as like we get where I have given 2 is a prime number, 2 is a prime number, true true. Others one also like false because they are not a prime numbers. Okay, so checking only here also, see else part is there at a for loop, means checking all the conditions, means like if one another if any condition is not in that loop, any condition is not get, so it directly ends the loop and gets the output, right? So that's why I have also given the else part here. Okay, here checking divisibility, and because the divisors repeat after that, and this reduces the drastically for the large. Okay, this is the time complexity, and space complexity is normal as like that, so much faster for the larger ones. Here you can observe that 10,000, so instead of checking 9,990 something numbers, you can directly check only for the 100 numbers. Okay, and yes, you are thinking that, oh, why we can't directly check for the even numbers also, right? So that we can also proceed after this approach. Okay, so here normally checking as like, but here using by loop function based prime check. Okay, here directly base condition is return false. Okay, for I range 2 to int plus 1, same as like limit we have used, and return false, I think same as like above, just giving here in a function, I think so maybe, or directly using, I don't know. Yeah, here see the function returns true if the number is prime, else false. Okay, it is, I think so maybe. Yeah, so cleaner and can be reused in the programs that deal with the prime ranges or prime factorizations. Okay, so error, like edge case handling is like handle with the function negative numbers, zeros, ones, these are like edge cases mostly we have used to keep in mind for the prime numbers, right? So here the most easiest way means like we can directly remove even numbers, negative numbers, or any one, any two, any three, like directly we can say like handle small numbers separately. We can handle small number before the loop for the cleaner and faster code, right? So see, you can observe here I am defined a function and return giving the user input and that printing, right? And directly saying that if the number is prime, we can directly say it is prime, or else we can return a not prime numbers. Okay, so here the main thing means handling small numbers separately, means directly checking if the number in 2 or 3 are like prime numbers, right? Directly returning yes, it is a true, or else, or any function means directly we have used like defaultly checking edge conditions, like if number is negative numbers or any one, then we can directly use this, right? Means like I mean, like here I'm excluding the negatives, 0, 1, and even numbers also. Okay, here I'm using the even numbers to exclude directly. If it is any number is even been directly returning, yes, it is a false, means it is not a prime number. Because if even numbers will divide, mostly have the multiple factors, right? So yes, odd numbers will have also multiple factors, but directly removing means mostly will be like that, right? So that's why it is excluding that even numbers, and here only check for the odd divisors since even ones are already handled, right? So for that I am using a here using a range from 3 to same that square root method, but here I am not directly used any math module. I'm directly here, it is directly using number power of this, right? Which is nothing but a square root. Okay, square root plus 1, same like limit method, and it is stepping up to 2 means 3, not 4, 5, not 6 and 7, not 8, not means 9, like only getting the odd numbers, and that numbers checking with odd divisors, like we have to checking the odd divisors. If number is divisible by the odd one, means if any number is divisible, then we can directly reason false. If it is not or it is an even, so means here directly check in, or means like a for the faster one. Okay, so that's why we have checking. So here you can observe the time complexity also, means in the square root method it is square root n time complexity, it is halved, right? So it is also most faster because directly checking each one here, right? So 2 and 3 handle, and yes, and we are skipping the even numbers after 2 and saves half the iterations, right? So useful when checking large values. Okay, so these are like, and approaches 5 same as like above, just using the all function. Let's go to see that all function is nothing but a built-in function that takes an iterable like a list, tuple, string, dictionary as an argument, right? And if it is true, then returns true, means truthy, means like see like a, if all the elements are truthy, right? Or if iterable is empty, if it is an empty or truthy, then it returns true. If even one element in the iterable is false, then all returns directly false. Okay, so you can observe here the falsy values. I think empty sequences will be considered as truthy because has set here like that. So you can observe here also. I don't think, I don't, yes, so okay. So you can observe here the list given most of thing and given a print, and with that, so you can observe here the output, that is all function of this gives true because there is no zero, no value. So you can observe the all elements are truthy, right? And it contains zero means falsy element, so that's why it returns false. And let's check empty list. So for the empty list it giving true, and for the string it is giving true, and for the empty string also giving true, and for the dictionary also giving true because there is no zero false terms, right? So that's why true, and here we have the zero, so that's why it is a false. So it is directly giving the false, like so. It is all function checks, or if all the conditions inside are true, then it returns true, right? So if n divided by any element, means number divided by any element is not equal to 0, it is like prime. So it directly checking here given like see input and is prime checking, n is greater than 1 and it should n should be greater than 1, right? And all is also checking same as like a for loop, as like above we did same checking. If it is all are true, then it returns true, means true and true is true, right? True and false is false directly, it's like an end operation. Okay, and printing that if is prime is like checking, if it is prime then it primes. Okay, so prints prime. Okay, so same, it is also same square root complexity, but it gives this due to generator internally. Okay, so these are like edge cases. Mostly we know that these are like edge cases, these are not primes, so we have to keep in mind. And these are like most and large numbers, and if the number is divisible by, right, divisible by another factors, then it is not a prime number, and it only have one and the number itself, it is a prime number. So okay, so that these things. Okay, constants are like they were mostly given in the ranges and giving the positive integers or not inputs, right? So should handle a large input, so avoid unnecessary loops unless. Okay, so mostly recommendation for the interviews is are like a approach one, loop based, intermediate, I think so maybe mm, square root method also, I think, right? Pythonic way approach 5 is also good, and this square root handle, okay, this one is also good, right? Because it shows root of, I mean big of square root of n by 2 time complexity, so that's thing I have used. So yeah, that's it for today, where we have to find the checking the means we have to check the number is prime or not. For that we have used the 5 approaches to solve that, right? So mostly by using the basic loop, by checking each one, like it is like a normally checking by like this and giving it is not a prime, right? So next approach will be like, and we have to keep in mind the edge cases. And next approach is by using the square root method, directly checking, importing math module and doing the math and converting that into an integer and using the square root and giving that. Okay, next approach is like using the function, same as like that we did above, just using the function is prime or not. Okay, directly giving, and it will be reusable, right, for for the purposes. Like mostly next will be used for the handle small numbers separately, right? It is, I think it is mostly useful and recommended, I think so, because it directly solves first one, right? So and ranges and give the same as like did we above. And next by, yeah, you can observe this. Okay, and next by using the all, it is also, I think maybe yes, good. So it is also uses the list comprehension way, so uses the all function same as like that above we have did. So these are the approaches to solve the problem for to finding the in number is prime or not, right? So these I have did. So yes, try to learn all these things, and I'm also improving, and you have to also improve with me. And yes, I will, I think we can meet in next video and checking each, I think prime number ranges to printing the prime number ranges, I think so maybe. So we will meet in the next video. Yeah, thank you for all, and meet you in the next video.